Okay, so we're back to our lesson on hypothesis testing, and we've just found a p-value of 0.0057 on our example about the pizza deliveries. So the question is that unlikely? Is it unlikely that, assuming H0 is true, we would get the data we got? To answer that question, the researcher decides before running the test on a cutoff value. The cutoff value, we call that alpha, the Greek letter alpha, or we call it the level of significance. There are three common values for alpha, 0.1, 0.05, and 0.01, and then of those three, 0.05 is by far the most common. And the rare event rule actually comes from that. It's the 0.05, if you remember, we said a probability less than 0.05 is considered rare. So probabilities that are unlikely are always going to be below that level of significance. So the rejection rule is always reject H0 if the p-value is less than alpha, the alpha given in the problem. Alpha will always be given in the problem. If you ever encounter one where it's not, just use 0.05. So assume 0.05 unless told otherwise. But regardless of whether your alternative hypothesis is less than, greater than, or not equal to, the rejection rule is always going to be reject H0 if p-value is less than alpha. And I feel like I sort of spend my life saying this, so I actually had a stamp made. You can go online and have a stamp made. And this is the results of that say reject H0 if p-value is less than alpha. That's how much of a dork your professor is. All right, so that's the third step of hypothesis testing, the rejection rule. That's the easy step. It's just reject H0 if p-value is less than alpha. For the conclusion, the conclusion is determined by the p-value and the rejection rule. So for our example, let's suppose we're using 0.05. Then our rejection rule is going to be reject H0 if p-value is less than 0.05. Well, we found a p-value of 0.0057, which is less than 0.05. So our conclusion is we will reject H0 and say that we can conclude the alternative hypothesis, which is that the mean of all delivery times is less than 30 minutes. So this tells us that supports the restaurant's claim. So for every hypothesis test, talking about conclusions in general, for every hypothesis test there are two possible conclusions. The one we found was the first one. Reject H0, there is sufficient evidence to conclude that, and we'd fill in with what the alternative hypothesis says. The other one is we fail to reject H0 and say that there is not sufficient evidence to conclude, and fill in the blank with whatever the alternative hypothesis says. So we would fail to reject H0 if we get a large p-value compared to alpha. If we get a small p-value compared to alpha, we reject H0. So let's do a second example. So the first example we did, the alternative hypothesis was less than. We're going to do one where it's greater than. So in this case, the mean weight of all newborn babies is 7.4 with a standard deviation of 2.3. Notice that this 2.3 is from the population, so that's sigma. And suppose we have 35 babies who were born to women who were diagnosed with gestational diabetes. Of those babies, we found a larger birth weight, and we want to test whether the average birth weight is for babies whose mothers have gestational diabetes is higher than the national average. So if we do this by hand, we've got mu equals 7.4 for the null hypothesis, mu greater than 7.4 for the alternative hypothesis. To fill in z star, we've got x bar, which was 8.1, so that's the sample mean, minus the hypothesized value, divided by sigma over the square root of n. If we do that, we get 1.8. For this case, because we have an alternative hypothesis of greater than, the p-value is going to be based on greater than. Okay, so if the alternative hypothesis is less than, then this sign here in the p-value formula is going to be less than. If it's greater than, it's going to be greater than. And I'm not going to ask you to do any by hand that are not equal to. That's a little different. So in this case, probability z greater than 1.8 using StatCrunch is 0.0359. They said in the problem use 0.01 for alpha, so we're going to reject h-naught if p-value is less than 0.01. Therefore, we would fail to reject h-naught because this p-value is not less than 0.01 and say that there is not sufficient evidence to conclude that the mean of this population is greater than 7.4. All right, so that's if I asked you to do that by hand. And I will ask you to do those by hand as well as in StatCrunch. So let's look at how to do that in StatCrunch. We've got StatCrunch up over here. So we're going to stat, z-stats, one sample with summary. So this is exactly the same place we were before with the confidence intervals. And let's see what our data was. We had a sample mean of 8.1, a standard deviation of 2.3, that was based on a sample of size 35, and our hypothesized value here was 7.4, and we picked greater than for this one. Okay, so our hypotheses were mu equals 7.4 versus mu greater than 7.4. We hit compute, and that gives us, it tells us what our hypotheses were that we said. This gives us our test statistic as well as our p-value. And from there, don't forget, you still have to state the conclusion. All right, so that's nice and easy in StatCrunch. So you may be wondering what the test statistic is good for. We're using the test statistic as a step on the way to getting the p-value. There is another way you can do the hypothesis test where you compare the test statistic to a given value from the standard normal distribution. I think that's harder. I think it's more work. It's not really used in the real world as much. So we're just going to stick with the p-value method. So for us, it's just going to be reject h-naught if p-value is less than alpha. You may see the traditional method in your textbook or some other places, but don't worry about that. We'll just use p-values. I need to mention a thing that comes up with hypothesis testing, and that's possible errors in the conclusion. And I don't mean errors that you would make an error in a conclusion. I mean it's possible for a hypothesis test. Well, let me show you. So, in a criminal justice case, sometimes the jury might make a mistake. They might wrongly convict somebody. So, back to what our hypotheses were. We said that the null hypothesis was innocent and the alternative hypothesis was guilty. So, if the jury wrongly convicts somebody, that's rejecting h-naught in error. So wrongly rejecting h-naught. Rejecting h-naught when h-naught is really true. So this type of error is called a type 1 error. The other kind of error, acquitting a guilty person, is going to be wrongly failing to reject h-naught. So failing to reject H0 when they really should have rejected H0, finding the person guilty. This type of error is a type 2 error. And in the criminal cases, as well as in our hypothesis testing, we consider type 1 error to be worse. And we set up mechanisms to minimize the probability of a type 1 error. And so hypothesis testing is designed to do that. We don't want a huge type 2 error either, and that's another issue that comes up with hypothesis testing, and that's called power when you look at type 2 errors. But we're looking just at type 1 errors. So the p-value, by the way, is the probability of a type 1 error. All right, so that's it for this lesson. I realize this is a big one, so you might want to go back and watch the video again, read the PowerPoint again, ask whatever questions you have. We can always do a video chat. It's very easy, and I think people have found it very helpful, so I want to put in a plug for that. All right, so that's it for this lesson then.